Hello everyone, I am Abhijit Singh from Spy Lab Electrical Engineering Department, Indian Institute of Sciences, Bangalore, and I'll be presenting our paper titled Study on Native American English Speech Recognition by Indian Listeners with Varying Word Familiarity Level, which is scheduled for presentation at COCOSDA 2021. First, we'll briefly talk about the relationship between non-native listener and English as L2 speech. Non-native English listeners find it challenging to recognize speech from a native English speaker, and their recognition performance depends on their experience and exposure to the English language. And this ability to recognize English speech is crucial for understanding various online content, such as massive open online courses, as the most of the mock instructors are native speakers of American English. Thus, quantifying the difficulty of recognizing Native American English speech by Indian listeners will be the first step to the solving problem at hand. Studies have been done showing that native listeners are better at recognizing the native speech compared to non-native speech in quiet and low noise conditions, and also compare the recognition performance in different noise environments like white and BAB extra. These studies show that the gap in accuracy between native and non-native listeners increases as the listening conditions become more challenging. Some studies look into the effect of semantic context on target word recognition and also analyze the effects of listeners' proficiency with a wide variety of language such as English, Mandarin, etc. Our study focuses on Native American English speakers and Indian nativity listeners and hypothesizes that the difficulty to recognize words in a sentence depends on their frequency of occurrence, foo score. The foo score of a word is the index of that word in the ANC frequency dataset. Foo score represents the familiarity of that word. Lower the score, higher the word familiarity. We categorize sentences into 3 word familiarity levels, easy, medium, and hard, based on their WS score, which is the sum of foo scores of all the words in that particular sentence. In this study, we majorly study the effects of control variables like word familiarity, speaker nativity, and listener nativity on the observed variables, which are 2 ratings from the sentence provided by the Indian listener. One is the rating difficulty to understand the sentence, and the other is the rating difficulty to understand the speaker's accent. And the third observed variable is the word error rate, which is calculated for the transcription given by the Indian listeners. Now, getting to the materials used for this study. We take 500 sentences of timid corpus which were listened to and recognized by 500 Indian listeners of different nativities, and each listener responded to the subset of 10 sentences. In timid corpus, we have nearly 2,300 unique sentences, and to select 500 sentences, we use the American National Corpus Frequency Dataset, which contains approximately 250,000 unique words sorted by their usage. Now, to get responses from the Indian listeners of varied nativities, we circulated 50 online Google Forms in undergraduate colleges and universities across India. These 50 forms were created using 500 categorized timid sentences. At least 10 responses from students aging from 19 to 23 with varied Indian nativities collected and analyzed. Each form contained 10 sentences, out of which 5 were easy, 3 were of medium category, and 2 were of hard category. There were 1,867 unique words in the selected 500 sentences, where 910, 556, and 401 belong to easy, medium, and hard familiarity, respectively. Distribution of speakers dialect region from 500 selected timid sentences for all 3 familiarity levels is given in the table. To get the observed variables in each of the form, respondent listens to the selected timid sentence audio clips and then transcribes the sentence to the best of their ability. The transcription provided by the listener is used to calculate the WER between the transcription and the original sentence. Then the respondent is shown the correct transcription and is asked to rate it on the basis of difficulty to recognize the sentence and the speaker's accent. The ratings are numbers ranging from 1 to 10. Higher the number represents more difficulty. Now, coming to the study outcomes. First, we'll be discussing the relationship between the observed variables. We find a 0.9 correlation between the sentence difficulty and speaker accent difficulty ratings. This implies that when a listener finds it difficult to follow a speaker, he or she finds it difficult to recognize the sentence as well. As both types of ratings are correlated, their relation with WER is also similar. In this figure, we have a percent WER across speaker and sentence difficulty ratings. As we go from rating 1 to 10, there is a steady decrease in percentage of easy and medium category sentences. However, the percentages of hard sentences are more evenly distributed over the rating range. This indicates that both the rating range provided by the listener closely follow the 3 word familiarity levels of the selected 500 sentences. In this plot, we have 3 observed variables: sentence rating, speaker rating, and WER for 3 word familiarity levels, easy, medium, and hard. We can see both the rating increases as word familiarity level goes from easy to hard, suggesting that word familiarity plays a significant role in difficulty perceived by the Indian listener. And the same trend is followed by WER, that is, WER increases with decreasing word familiarity level. We observe that the percentages of transcription with exact match, that is 0 WER, decreases as we go from easy to hard word familiarity level. This suggests that word familiarity significantly alters human speech recognition performance. As this study is performed on the Native American speakers' recordings, Native American listeners would achieve the best recognition performance. However, an ASR built on American English has been used as a proxy for a native American listener in this work. We also experimented with ASR built with Indian data for comparative analysis. In total, we trained three ASR systems. First one with its acoustic model trained using 275 hours of 81 Indian speakers speaking sentences from Timid corpus, which we call iTimid corpus, and the language model for this ASR system is trained on Timid data. For the second ASR system, both the acoustic and language model were trained using 960 hours of Libri speech corpus data, which contains American accent speakers. And the third ASR system acoustic model is same as ASR2, but the language model here is trained on both Timid as well as Libri data. Now, here in this table, we compare all three ASR system and HSR performance we got from online survey. We observe that WR for both HSR as well as ASR system decreases as WFL increases, implying ASR also performs poorly for the sentences with less familiar words. This could be due to the lack of training data for these words. In case of ASR1, we see that it performs poorly for easy rather than medium or hard sentences. And this could be because of poor performance of acoustic model due to accent mismatch. And the LM helps more in case of difficult sentences, that is with less familiar sentences. As for ASR2, performance is consistently higher than HSR in all word familiarity levels, suggesting that the AM trained with American accent corpus further improves the WER. As we go from ASR1 to ASR2, we observe a significant decrease in WER, and this is because the acoustic model of ASR2 was trained using American accent data rather than Indian accent data. In case of ASR3, the acoustic model is similar to that of ASR2, but the performance increases due to the inclusion of timid data to the training of language model. This significantly affects the ASR performance as Libri speech text covers a wide variety of English words, and timid text covers less familiar words as well, which may have been missed by Libri speech. Now, coming to the impact of speaker nativity on speech recognition performance. In this figure, we have plotted histograms of WR percentages for easy, medium, and hard WFLs, and the yellow one, which includes all the numbers across all nativities. Here we observe that higher the word familiarity level, lower is the average WR except for dialect region 8 and 5. WR numbers for speaker nativities on the extremities of the plot are significantly different, such as DR4 and DR5 are significantly different from DR2 and DR8. And this reveals that the dialect region of the Native American speaker is one of the key factors to influence the recognition accuracy of Indian listeners. Here, we compare speaker ratings across all speaker nativities using a box plot. The dialect regions are ordered in descending average speaker rating. We observe that dialect regions 4 and 5 have the highest speaking ratings and are significantly different from the rest of the dialect regions, implying that the Indian listeners' recognition accuracy depends on speaker's dialect. According to the plot, we observe that Indian listeners find speakers from dialect region 8, 2, and 7 easy to follow compared to the rest. Now, we'll look into the impact of familiarity on the word deviation, which is the difference between the number of words in the original sentence and the transcript provided by the Indian listener. Looking at the table, we see that the negative deviations are much less as compared to their positive counterparts, and this could be due to the listeners missing the spoken words rather than inserting new ones. In case of exact matches where word deviation is equals to 0, the percentage of deviation decreasing with lower word familiarity level. This means the easier the sentence to understand, higher the probability of an exact match. But the opposite trend is followed for the rest of the word deviation, which is a given because as the difficulty increases, more are the chances of mistakes. We also analyze the word deviation across speaker nativities and find dialect regions 4 and 5 have the least percentages of sentences with exact matches. This suggests that Indian listeners find American speakers from these regions most difficult to understand, which was evident from the speaker ratings as well. Here we have an analysis on the nativity of Indian listeners and their respective WERs. In the table, average WERs are given for the 5 most prominent listener nativities. We observe that Telugu, with highest WER, is significantly different from Kannada, Hindi, and Tamil, whereas Bengali is significantly different from Hindi and Tamil. These significant differences could be due to the amount of exposure to American English in addition to the nativity-specific factors. Now let's summarize all our findings and move on to the conclusions. Observed variables such as sentence speaker difficulty ratings and the WR significantly increase and decrease in word familiarity level, implying WFL significantly impacts non-native listener perception of difficulty level and speech recognition performance. Speakers from dialect regions 4 and 5 that in certain parts of America were found to be difficult to be followed by Indian speakers. And in listeners, nativity also plays a significant role in speech recognition. ASR1 performance is similar to that of HSR, as ASR1 is trained using Indian data. And when we use American data for training, the ASR performance improves significantly. Deviations in the number of words rises with lowering word familiarity level, implying that Indian listeners find it difficult to identify the number of words in a sentence containing low familiarity words. At last, we thank all subjects for their participation in the study. That will be all from my side. Thank you for listening. And if you have any questions, please write to us at spirelab.ee@isc.ac.in.